Welcome everyone on the second episode of the HydroTalk podcast series organized by the early career scientist members of EGU's Hydrological Sciences division. I am Archita and with me is
Melissa Reidy. And with us today we have two podcast guests. We have Dr. Ilja van Meerveld, and she's a group leader at the Department of Geography at the University of Zurich. Her research focuses on the relation of hydrological processes with landscape and vegetation. She uses both modelling and field-based approaches, and she's also one of the people who coordinates the CrowdWater citizen science project. And we also have Sara Blanco, who's a PhD student joining us from Costa Rica, who works on the project for CrowdWater as well.
Excellent for having us.
Welcome Ilja and Sara. I'll start with you, Ilja. Can you share with us your professional journey? What sparked your interest in research, specifically hydrological research?
Yeah, I think I largely really just rolled into it. I never planned or thought about having a career in science or as a researcher. When I was in high school and was thinking about what to study, I saw a short information movie about studying physical geography and geology, and I really liked it. I liked that it included science, that it had geography, that it had history. That's when I decided to study physical geography. From there, I rolled into hydrology, maybe partly because hydrology had to do with water, and I could see maybe careers where I could use this. I grew up in a region called Waterland, which means water and land. So I was familiar with water. Then when I finished my master's degree, I really enjoyed what I was doing for the thesis. And when someone mentioned that maybe I should do a PhD, I thought, that would be fun to do 4 years more research and working on this. And I thought it would be really nice. And then even after getting my PhD, I had no real plans, but then there happened to be an offer for a postdoc that sounded really interesting. And I guess that's just how it went, and I rolled into it.
Excellent. Part of your research focuses on how the different landscape variables like vegetation, heel slope, etc., control stream flow. Can you tell us a bit more about your research work?
A large part of my research focuses on a run-off generation mechanism, so which path the water takes towards the stream, and among other things, how this is affected by land use change. What we know and see is that how the water moves to the stream depends on a lot of factors that vary from catchment to catchment, so soil, topography, but also climate, and it also depends on land use. And I think this is a really interesting topic because there are so many factors that affect it. I also think it's really important to understand really those processes about how water makes it to the stream, because that is what we need. We need to know how it flows towards the stream if we want to predict how much water we have in the stream, or how these streams may respond to extremely big events or very dry periods. If we want to have models that work well, we really need to know these processes first. And then vegetation is one of those factors that really has a large effect in how water moves to the stream. It's also the factor that we as humans tend to change the most. How we manage the land affects then how much a stream responds to a rainfall event, or how maybe things like nature-based solutions then affect how streams respond to large rainfall events.
I was really interested to know about a very particular thing that I read a paper of you about, that is related to vegetation and how this is not the only solution for the hydrological extreme events like flood and drought. So can you tell us something more about how vegetation is not the only solution, and what are some interesting results that you found?
Yeah, I think the paper that you're mentioning is all about low flows, how maybe planting trees is not always the solution to manage low flows. If we think about hydrological processes, it's actually really complicated, because on the one hand, when we have more trees compared to maybe grasslands or croplands, these trees tend to increase the evapotranspiration, so there is less water available. On the other hand, these trees can improve the soil structure, improve infiltration, so that there is more water going into the soil, which may mean there is more recharge, which may mean there is more water for the dry periods. In addition, then these trees also change how maybe the rainfall patterns further downwind. And so there's a lot of interactions here. And the effects are really very site-specific, very climate-specific, very dependent on where this catchment is located or where we plant trees in the catchment. It's actually really complicated. And in that paper that you're mentioning is where we're saying, okay, what we need to do is to study these effects. What determines whether these effects of tree planting on low flows is positive or negative, so that we have a better understanding where in the landscape, if we plant trees, and we can do this for many different reasons, but we need to be honest about what the hydrological effects are. It may be that planting trees is very good for biodiversity, is very good for carbon, but if it leads to lower low flows during the dry periods, we need to be honest and say that. Unfortunately, at the moment, we don't really have a very good grasp or a way to predict where these effects are positive or negative. That's what we wanted to highlight in that paper.
How do you exactly generate the data on whether planting trees is increasing or decreasing the stream flow?
Yeah, so this is the complicated part, right? This is where I think why we are not there yet. We have models that tend to predict whether trees increase stream flow or not, but these are based on parameters, and often it's a very simplified way that they do this, and there is not this interaction. So what we need really, in my opinion, there is field data, and this is what we're often lacking, especially in locations where tree planting may be very beneficial for many things, where we have degraded soils, where tree planting really changes the soil structure and therefore the infiltration. So I would be a big fan of having more field studies in a range of conditions, or actually measuring during replanting programs what is happening to the hydrology, because now often we have reforestation programs, we look at how well the trees are doing, but we're not really at the same time monitoring what's happening with the water.
I have a question just to follow up on that because I'm in Sweden, and in Sweden we have a lot of research going into riparian buffer zones. Can be sometimes quite a controversial topic because forestry is quite widespread in Sweden and other Nordic countries. You've talked about reforestation, but have you looked at the sort of the flip side of that in terms of clear cutting or reduced riparian buffer zone widths, or sort of mixed buffers? Like, does any of your work touch on that?
No, not necessarily. Of course, hydrology, especially the hill slope hydrology, catchment hydrology, part of the hydrology that I'm from, it has often been sparked by questions regarding forests and water. Most of our famous research catchments have been established in order to study how, especially deforestation, affected water resources. And we know there that if we cut the trees, there is going to be less evapotranspiration. Generally, stream flow goes up. There's still a lot of debate on what happens to the largest of the peak flows. And generally, what we see in many locations in that case is that the low flows go up as well because there is less evapotranspiration. But a lot of these types of experiments, especially also in the past, are generally done under very controlled conditions, whereas in a lot of real life situations where we maybe have deforestation and then agriculture, we see that it goes hand in hand with a lot of changes in the soil structure and soil degradation. And that's, of course, very different if we're in a forestry setting and depending on the ways that the trees are being harvested.
It just sounds so complex and such an interesting problem to try and solve because you've got so many variables coming into it. It would require quite a lot of, I suppose, different types of hydrology and collaboration and interdisciplinarity. That was just a comment. I'm just fascinated to see where it goes from here.
Agreeing with you.
Yeah.
I also think it's very interesting, and I think it's this complexity and working together with different people in different fields that makes it also super exciting and interesting and fun to do.
Yes, this all sounds very exciting, and I wanted to talk to you about another exciting project that you are a part of, which is a citizen science project called CrowdWater. So this project, basically, what I understand, involves hydrological data collected by the citizen scientists. Can you tell us something more?
Sure. The citizen science, where we involve people from the general public in data collection or data analysis, is not just limited to hydrology, but we look as hydrologists in how we can use this in hydrology. And there are different ways that people can be involved in data collection. And one way is, for example, where people observe water levels or changes in the water levels. They can observe how much plastic pollution there is in the rivers, or they can observe for streams that occasionally go dry. Are they flowing now? Are they dry now? The color of the river or the sediment in the river. In a way, citizen science is not very new. People have been involved in hydrological monitoring for a very long time, because it was citizens that measured rainfall, that measured snow depths, etc. So there's different ways depending on how and in which project, what you're interested in, that citizens can observe.
This question is for both Ilja and Sara. Why is it so important to gather so much data from so many people?
Maybe I start and Sara can give a very specific answer for specific locations. It depends very much on where you are. One reason why it's very important to get hydrological data is because we have, for example, gauging stations at a few rivers, definitely not everywhere. Even in Switzerland, where we have a lot of gauging stations, we do not have so many on small streams or in the mountains, just because it's very expensive and difficult to measure stream flow. There are other places in the world where we have very, very little data, and very little data that is publicly available. If we think about water management, it usually requires a hydrological model, a hydrological forecast, and these models that are used for that are calibrated. For this, we need stream flow data, or even if they're not fully calibrated, we need to double check how well these predictions are. And for that, we also need stream flow data or stream level data, for example. And if we have no data at all, what's the case in very large parts of the world, we have no ways of really getting good models, getting good predictions, having a good way of managing the water. Maybe Sara can say something more from a local perspective on why it's also important for people to have hydrological data available to them.
I think part of the research in CrowdWater is focused on evaluating the accuracy or the quality of the data that is collected, because this is an important question in citizen science. It's often a question about how accurate or how good is the data. And I think something I like and something that I find important in CrowdWater is that finding the good quality of the data is not only important for scientists, but it's also for the citizen scientists. It gives credibility to the data. It also makes them confident about the data and the information that they are collecting. Sometimes people need the data to prove environmental damage, and if they have the proof, the scientific proof of that, it makes very valuable the experience of participating in a citizen science project. I think CrowdWater is also a very accessible tool. And I think another important thing is that local people are often more aware of environmental changes and also environmental hazards than monitoring agencies, for example, or than scientists. And with CrowdWater, people are able to collect data based on their own experiences, on their own knowledge, and also on their own interest. So there are some places which are studied very intensively by scientists or by monitoring agencies, and there are other areas which are not monitored. And with CrowdWater, it makes possible for people to kind of put in the map these places which are often not considered for traditional monitoring processes.
So how do you make sure that all the data that are being produced are reproducible, they are standardized? And it's a question to both of you.
One way that we have done in terms of credibility of the data is going out and testing this. For example, in different projects, we've gone out to rivers, for example, where there was a hiking path or in a city, and then asked people, what is the level in the stream compared to a photo? Is it higher? Is it lower? Is it much higher? Is it much lower? Or to go to a stream that is sometimes dry and say, hey, which of these classes do you think it is? Is it flowing? Is it barely flowing? Do you see isolated pools? Do you think the stream bed is wet? Do you think it's dry? Which of these classes that we use in the CrowdWater app do you think it is? And by this, what we can see is that many people agree. Of course, not all people choose exactly the same category, but in general, they are very close to each other. So there is really something in that case. Many times it's called the wisdom of the crowd, but it also means that it's reliable, that if I go today to the river and say it's a certain level, or it's a certain flow class, and you go tomorrow, that actually those differences are not just because I interpret it different from you, but actually because we agree, or we tend to agree on our assessments. And this really, by proving that, helps with the credibility of the data. That way, citizen scientists can go out and collect these data and say, hey, these are good data because these people have already proven it. The other reason or way that we can add credibility to the data is that, at least in the CrowdWater app, you always upload a photo of the river or the stream in front of you as well. And that's an extra piece of information or an extra evidence of the situation.
I found in a group in El Salvador, for example, they wanted to kind of compare what people were saying about the river, but they needed scientific evidence for that. And for them, it was important to collect perceptions of the people about the river. And then they also did some physical-chemical measurements about water quality. And that was a way to complement both sources of data. But I think it was also important for them to have these two different perspectives and to say, okay, we have kind of an agreement.
I'll fully disclose because I use CrowdWater and I play the CrowdWater game as well. I think I really, really like it. I've been taking various pictures of a stream here for a while. How did you decide to develop an initiative that puts so much stock in citizen scientist data? Because I think it's so great.
This largely comes from this notion that in hydrology, we are a data-limited science. We have, for many rivers, almost no data. And some things are relatively easy to observe. It's somewhat easy to observe if I pass by a bridge every day, walking my dog or going to the train station or some other way, that the river is a different color or that the river is higher than yesterday. And it's a way of getting people to help collect data. It's also a way of engaging people in environmental monitoring, making them aware of the environment, realizing that the river is actually very exciting and interesting, and there are a lot of changes happening throughout the year.
Do you get enough engagement?
That's the thing with citizen science. It all depends on how many people you have that are willing to participate. And this requires effort and time in building communities. As with all citizen science projects, I would say for CrowdWater, we have a small group of people that are contributing regularly, an even smaller group of people that collect a lot of data and a lot of observations. And there are a lot of people that open the app. They're not taking a lot of observations, but that's okay, right? It's the people that collect data regularly that's almost the most useful data, because we get time series from them.
I think we are biased because we get engagement and we get engaged with people who are very engaged. And then I have the feeling that many people are very interested and engaged in the project. I think it really depends in the area, of course. It depends on the purpose that people have while using the app. Sometimes people just do it because they enjoy using the app and being outdoors and they want to contribute to the project. There are other cases where people have specific concerns and they have a specific purpose, and they found the CrowdWater app as a tool to collect or to register this information that they are aware or that they are concerned of. So I would say it really depends, as in many other citizen science projects. But I would say that something that surprises me about the project is for how long it has been running, and that the amount of citizen scientists or the people who are engaged is always increasing. There is always a new project, a new organization, a new person who is writing to the CrowdWater email, showing interest, or even telling us a new way to use the app in a specific context. So I think that's the kind of engagement we get.
That all sounds very positive, but can you also touch upon the barriers?
Yeah.
What are the main accessibility barriers?
Yeah, I find that the barrier that we face the most is basically the technological divide, because as Ilja said at the beginning, the idea of the CrowdWater app is to become like an accessible tool that can be used in areas where there are limited resources for monitoring equipment or for monitoring efforts. But we have to think that in those areas, sometimes there is also less access to education, or there is less access to technology, to internet. So I would say that the main challenge is to go to those areas and to really engage with people through the technological device. That is the main component of CrowdWater.
In those cases, sometimes you can see that NGOs are trying to include the local people. Do you also tend to engage with those type of groups?
We often get contact by organizations that are working on local communities, and they have a specific project, so they already know the people, they already know the rivers, or they already know the area, and they already have kind of like a monitoring strategy, and they know that CrowdWater can complement these strategies or these processes. So we often engage mostly with organizations or with local groups.
I would say it's two types of people, what Sara just mentioned, NGOs and groups. And then, of course, we have the individual citizens, the individual people, maybe in Switzerland or in Germany, that like to go out, or in Sweden, for a walk, have their river there, become attached to it, and they make regular observations there.
I would really like to know if this citizen science data has been used. Do you get any interesting results using this data?
So yes, we have used the data. For example, we've used it to show that the data are good, that they're reliable, but we've also used it in a way in hydrological modeling to show that these data are useful for calibrating a hydrological model. Other people have used it to test different approaches. For example, we have pictures of these rivers to use AI training to see what's in the river, what's the type of plastic that's floating there, or are these rivers dry or not flowing.
Here in Costa Rica, they're using the app mainly to follow up on restoration project in urban rivers. I know there is another group in Mexico, for example, they use the temporary streams category to monitor also changes regarding land properties also. So they also want to monitor where the river is flowing, and if that basically kind of create a conflict regarding land grabbing. Then I know that there are other groups in Colombia, they're doing monitoring regarding water level. And there is another group in Chile, they did 4 years of water level monitoring. And at some point, they also contact the group to go further with the data and to calibrate a hydrological model with the data they were collecting. I think there are many applications that we are even not aware of.
Yeah, maybe in addition to the examples that Sara gave from Latin America, one other one is, for example, people in the city of Leiden in the Netherlands, they used the app to really monitor how much plastic was in the water in their city and whether cleanup measures were necessary, if the cleanup measures were working. Many different ways that the data can be used, locally or in scientific.
If someone wants to get involved, but they're sort of on the fence, they're not quite sure whether their input is going to add any value, what message would you like to give them?
I think it's interesting. Often people get very scared of doing something wrong in the app. But I would say that if the person is already interested on that, then just to try it out. There are many possibilities with the data and also within the app, and that there is no way that it can go wrong.
Yeah, that's exactly what I wanted to say as well. The app is freely downloadable. Anyone can make an account. You can use it. There's not really anything you can do wrong. It's designed in such a way that it should be relatively straightforward to use. In addition, there are videos online and sort of short handouts on how you can and use it. Just do it and see how it goes. Earlier, there was the mention of the CrowdWater game, which is a game designed to look at data quality. And what we see there is that once people have done it twice, they're getting much better at it in understanding what they need to do. It goes much faster. It's really a matter of trying it and then giving it a second chance. If you first time were like, what do I press, which button? For anyone who's anyway used to apps, it should be very straightforward.
Great, that means just get started. It cannot go wrong.
Exactly.
We are almost approaching the end of the interview. but we would really like to ask Ilya two questions. The first one is, in your view, what do you think is the biggest breakthrough in hydrological science in past, and what is the trend for the next few years?
Yeah, that's a difficult question. But I think in terms of breakthroughs, I think when I think about hydrological processes and hydrological understanding, I would say it's the use of tracers that have really brought the biggest breakthroughs. And that's not just the last 10 years, it's probably the last 30 years. But I think in the last 10 years, we have come to the realization that where the water is flowing, through the bedrock, it's a much larger storage of water that we have. The water is moving deeper, the water is moving much older than we probably thought in the past. So it's due to the use of tracers, due to the use of field data that I think we have increased our understanding there. For the next 10 years, it's a little bit more complicated. I think many people would say something related to AI and data. And I think we are going to see a lot of really great things happening by the fact that more databases are being available, and this data can now be used in terms of hydrological modeling, not just for one catchment, but for many, many catchments all across the globe. So what they call this large sample hydrology, but probably in terms of breakthroughs in understanding how water moves through our landscape, I would say it's probably still going to be related to the use of tracers, maybe different tracers, probably also related to interdisciplinary research, maybe related to the critical zone, people that study hydrochemistry working together with hydrologists, working together with ecologists, that relationship, maybe hopefully what we started about vegetation and water. The vegetation is really dependent on the water, and we see patterns in vegetation due to the water, but then the water also, the way it moves through the landscape is affected by this vegetation. And I think, or I hope that in the future or in the next 10 years, we will learn much more about how these relations are and how these affect each other.
Great. So the last question is your best piece of career advice and your worst piece of career advice that you would like to share with the early career researchers.
I'll start with the worst because it's not bad in principle, but I think it's also related to what I think is the better piece of advice. There's a lot of advice on the internet and on books where people say you need to be very strategic. You should only do things that you get an immediate reward for, that you get a lot of prestige, but maybe not so much work for. And I think that's a bad piece of advice because that's not how communities work. The better piece of advice is not something that someone ever said, but something that I read is like, everyone is smart, be kind. And I think that is what gives you a lot of leverage, because this brings joy in what you're doing. You get to work with people that are really nice, that you enjoy working with, and you maybe end up in a citizen science project working with people, and you learn so much from all of these different people that I think is in the long term a really good strategy, because having friends that you can work with and not just colleagues is really nice and really rewarding. Now, having said that, of course, that doesn't mean that people should spend all of their time being nice or all of their time only baking cakes for their colleagues. But there is also something that, always being only doing things because it gives you an immediate reward or doing the bare minimum, I think is in the long term not very good strategy.
Thank you so much. Thank you, Ilya. Thank you, Sarah, for joining us. It was great having a discussion with you guys.
It was very nice talking to you.
Thank you very much.